Hello students, welcome back. Let's resume our discussion in the first problem. In the first video, we talked about the 95% confidence interval. Next, we talked about 95% prediction interval in the second video. Now, I added one more problem here, 95% lower confidence bound. By the way, if you go over to original problem set, you don't see that here. I wrote 95% confidence interval for the mean, and 95% prediction interval for one individual. For confidence bound, I didn't write it in the original exam problem. That's because exams are always bounded by a certain time, but this is a review session. I don't have to be bounded by that, so let's do the lower confidence bound. I can do upper confidence bound as well. Mathematically, pretty much the same, except we have plus versus minus. But in this particular case, lower confidence bound makes more sense because we are talking about some strength of some lumbar beams. And if the batch of lumbar beams are exceptionally strong, that's not a problem at all. But if you have some exceptionally weak lumbars, now that's going to be a major problem. So that's what we are more interested in, lower confidence bound in this particular case. Okay, let's begin. Here's the initial picture. An initial picture is not symmetric this time. We are looking for lower confidence bound, you see. So we have this one. Oh, by the way. Okay, I better copy and paste this thing here. Okay, this is a sample statistic. And then we have the picture. And then the center is 7,203.091 psi. Excuse me. And then end is something we have to find out. Only lower end matters here because we are looking for lower confidence bound. This is for 95%, so this part all the way toward the right hand side is 95% of total. So the other 5% will show up here in blue part. Okay. So much for the picture, and let's go over to the technical part. The degree of freedom is 30 minus 1, n minus 1, so it's 29. And then let's work out the t-table. N minus center over SE, yes, but the t statistic turns out to be negative 1.699. Is it really? Let's go to the t-table. And then let's go to degree of freedom of 29. It's here. Yeah, all those here. Okay, and then we are looking for 95% confidence level. So is it gonna be this one, 2.045? No, not really. That's not the case. Because if you do that, that means we have 95% in the middle. So we have 2.5% here and 2.5% there. That's not what we are looking for. We are looking for 95% in one side. So the other 5%, not 2.5, but 5% should be the shaded part. So we have to look at this column here where I'm running my mouse. 5%, 0.05. And let's go down a little bit toward 29. And what do you have? 1.699. That is my t-statistic. 1.699. But then again, what is this negative? Let's go back to the t-table again. Oops, that was the table. Sorry, this is a t-table. All these numbers you saw about right hand side. Okay, this is the center. 0, and then plus some t value, and then we have this blue part there. Now let's go to our problem here. Where's the initial picture? Now I'm looking for the left hand side. This is the center, and I have to subtract to go down. So we need a negative sign there. Not the right, but the left. So we need a negative sign. That's what this negative sign is all about. Not just 1.699, but negative 1.699. Once you saw that, it's just an algebra. Here we go. end minus center over SE is negative 1.699. So what do you have? End minus center. X is the end you're looking for. Let's go to the picture again. X end minus center 7,203. End minus center is the numerator. And SE, standard deviation, S over square root of n. So we have this equation here, and let's solve it. Flip this denominator to the other side, multiply by that, then what do you get? Negative 1.699 times that denominator. 5.42.540 standard deviation, over square root of 30. This whole thing is called standard error, by the way. And flip over this one to the other side, so we have plus, and then that. Run your calculator, and what do you get? 7,334.799, approximately speaking. And here's our conclusion. 7,034.8 psi, approximately speaking. And that's the left-hand side endpoint here for this one-sided confidence interval, the red part. And that is the lower confidence bound